In this episode of our tutorial, I will be solving some questions under the topic mole concept. On the board we have 4 different questions under the topic mole concept. I will be solving these questions one after the other. Number 1, calculate the number of moles in 9.03 times 10 raised to the power 23 atoms of it. In this case, we have to look at the values given in the question. We have just a single value is given in the question now, which is the number of atoms. Number of atoms, that's 9.03 times 10 raised to the power 23. If you could remember in our last class, I gave 3 different ways of finding the number of mole of substance. So the first one was the use of the Avogadro's constant. In this case, we can use the Avogadro's constant to find a number of mole. And the formula says mole or number of mole is equal to number of particles over Avogadro's constant. And what's the value of Avogadro's constant? That's 6.02 times 10 raised to the power 23. That's the value of our Avogadro's constant. So using this formula, we can get the number of mole or the mole of the substance or the atom involved here. So the number of particles is also the number of atoms, and it could also be the number of molecules if the substance is involved there is a compound, and it could also be number of ion if the substance here is possessing the charge. But we are having this atom, so we are using the number of atoms. Number of atom is 9.03 times 10 raised to the power 23. The Avogadro's constant 6.02 times 10 raised to the power 23. Therefore, the number of mole here is 1.5 mole. After calculating for this, we are going to arrive at this 1.5. That's number 1. Now let's go to the second question. The second question says 44,800 centimeter cube of camphor oxide molecules are absorbed by a tree every day. How many moles of camphor oxide does this represent? In this case, they gave us only one value in the question, and the only value given is the volume of the gas involved in the question. So volume of gas is equal to 44,800 centimeter cube. Now to find the number of mole of a substance using the volume of the gas involved, that's CO2, using the volume of the gas involved, one thing we have to make sure is that we have to make sure the volume of the gas is in dm3. We have to make sure the volume of the gas is in dm3 before we can proceed with our calculation. That is, there is a formula which you can use to solve a question like that, and that is mole is equal to volume of gas in dm3 over molar volume of gas at STP, which is also in dm3. And that is what? Volume of gas. What's the value of the volume of gas? That's 44,800. Here we cannot use 44,800 directly. We have to make a conversion. Converting from 44,800 centimeter cube, we have to convert it to a value in dm3. How do we do that? So we say volume of CO2 is equal to 44,800 over 1,000. So we are going to have 44.8 dm3. So that's our value in dm3. When you convert 44,800 to centimeter cube, when you convert it to dm3, you are going to have 44.8 dm3. You divide the value by 1,000 to get the value in dm3. So we come back to this. Therefore, mole is equals to volume of gas. The volume of gas now is 44, that is the volume of carbon dioxide. Now it is 44.8 dm cube over 22.4 dm cube. 22.4 dm cube. Blood volume at STP. Blood volume at STP. 22.4 dm cube. So in this case, for 4.8 over 22.4, we are going to have 2.0 mole. Our value is going to be 2.0 mole. 44.8 divided by 22.4 is going to give us 2.0 mole. Here we use the second method I gave in the last video, using the molar volume of gas to find the mole of substance, using the molar volume of gas and the molar volume at standard temperature and pressure. In the first question, we use the Avogadro's constant to find our number of moles. Now, number 3, here the question says, calculate the number of moles in 12 grams of magnesium. Here, I will be using the third method I explained in the last video, which is mole is equals to mass over molar mass. Mass over molar mass. Now, what are the values given in the question? The mass is 12 grams. The mass of the atom, which is magnesium, involved is 12 grams. The molar mass of magnesium is equals to 24 grams. 24 grams per mole. Yeah, that's the unit of molar mass, 24 grams per mole. This is the relative atomic mass. So when you express it in molar mass, you add the unit to it. So we come back to this. Mole is equals to the mass, the value of mass 12, the value of the molar mass 24. So we say 12 over 24 is going to give us 0.5 mole. So that's the answer for the third question. In the third question, we have to use the value of the mass and the value of the molar mass to find the value of the number of moles. Now, in our fourth question, the fourth question says, calculate the number of moles in 53 grams of sodium tricarbonate 4. Calculate the number of moles in 53 grams of sodium tricarbonate 4. Given that sodium is 23, the relative atomic mass of sodium 23, relative atomic mass of carbon 12, and the relative atomic mass of oxygen is 16. In this question, to solve this question, we have to use the same method we used in the number 3. We have to use the same method to solve this question. And what's the method? Using this formula, mole is equal to mass over molar mass. So what's the mass? Number 4. The mass given the question is 53 grams. So what's the molar mass? Here, a compound is involved, unlike the third question here, which involves only a single element. Here, a compound, a group of elements is involved, which is two atoms of sodium, two molecules of sodium, 1 atom of carbon, and 3 molecules of oxygen. So the molar mass is going to be the combination of their relative atomic masses in proportion, like it has to be in relation to the proportion of each atom present in the compound. Here we have sodium to be 23, and then we have 2 molecules of sodium here, so we are going to have 23 times 2 plus, here we have carbon to be 12 and 1 molecule of carbon here, so we say 12 plus, and here we have oxygen to be 16, and we have 3 molecules of oxygen here, so we are going to be having 16 times 3. So everything together we are going to be having 23 times 2, that's 46, plus 12, and 16 times 3, that's 48, plus 48. Everything together is going to give us 106 grams per mole. 106 gram per mole. So 106 gram per mole. Then we come to our formula. Mole is equal to mass over molar mass. The value of our mass is 53, and the value of the molar mass is 106. So 56 divided by 106 is going to give us 0.5 mole. So that's the answer for the last question, which is this, or the answer is 0.5 mole. In the first question, they asked us to find the number of mole, giving us the number of atoms. That's the only thing given in the question. What they expect us to do here is that they have expected us to know the value of the Avogadro's constant. So we use the Avogadro's constant and the number of atoms or the number of particles given in the question to solve for our value. In the second question, they gave us the volume of the gas involved. Here we use the formula mole is equal to volume of gas in dm cube over molar volume of gas at STP, which must also be in dm cube. Before you can use a formula like this, you have to ensure that the question is involving a gas, because we are solving in terms of the molar volume of gas at STP, which is 22.4 dm cube. So if the substance is not a gas or is not in gaseous form, we cannot use this formula to find the value of the thing involved in the question. So another thing here is that we have to ensure that our 44,800 centimeter cube of carbon dioxide is existing in dm cube, or make a conversion from centimeter cube to dm cube. By dividing by 1000, we are going to arrive at 44.8 dm cube. On the third question, calculate the number of moles. Here they gave us the gram, that is the mass, and the molar mass, the relative atomic mass, that's the molar mass. So when you use the mass and the molar mass, we're going to be using this formula when a question is involving something like this, having the mass and the molar mass, and we are asked to find the mole. We are going to be using something like mole is equal to mass over molar mass. The same formula which is used in number 3 is used in number 4. The only thing different there is that in number 3 we are dealing with an atom, while in number 4 we are dealing with a compound, and a compound is a group of atoms. So the relative, to find the molar mass, you have to add all the atoms present in the all the atoms present in the compound, you have to add them together to find the molar mass, and in the right proportion. Here we have two molecules of sodium, so you have to multiply it by this value of the relative atomic mass of sodium. Here we have one atom of carbon, so 12 times 1, 12, and here we have 3 molecules of oxygen. 16 times 3 is going to give us everything together is going to give us 106 grams. Then we solve for this using the same formula as number 3. So thank you for watching this video. Please like, subscribe, and share this video. God bless you. Thank you.